Hello, this is Mrs. Taylor, and I'm going to show you how to solve this real-world problem with a linear equation. This looks like three separate problems, but it's one problem. I've just broken it up into three chunks so that it's a little bit easier to process. First part says a rental company is running two specials. Customers can pay $50 to rent a compact car for the first day, plus $6 for each additional day. So linear relationships, there's a pattern to the way they are described. So sometimes you'll have a flat amount. So here we have a flat amount of $50. That's our initial amount. That's what we'll pay no matter what. And then you have a rate. So sometimes it'll say $6 for each additional day, or it could say $6 per day. Either way, for each day, per day, that indicates a rate of change. And so when we write an expression, an algebraic expression to represent this, we have to keep in mind that a rate involves multiplication. If it's 6 for each day, then I would take 6 and multiply it by the number of days. We don't know how many days there are, so that's where you get the variable x. So $6 for each day can be represented as 6x algebraically. And then we can't forget that starting amount of $50. It's there no matter how many days. So I add 50 to fully represent this cost, $50 plus $6 each day. The next section, the second special, is customers can rent the same car for $40 for the first day. So there's a flat amount, initial amount, and $8 for every additional day beyond that. So there's our rate. And so it will look a lot like what we just created. 8 for every day would be 8x. We don't know how many days there are. And then there is that initial amount of $40, so we add 40 to that. So I have an expression for this first company. I have an expression for, I have an expression for the first special. I have an expression for the second special. Now let's move to the third part. Elise notices that given the number of additional days she wants to rent the car for, the two specials are equivalent. There's a math word, equivalent, equal. How many additional days does Elise want? So we need to find the number of days. Well, which variable represented days? If it's 6 for each day, 8 for each day, 6x, 8x, x is our number of days. So what I'm really trying to find is, what does x equal? And they told me that the two specials are equivalent at some point. That means they're equal. So if this expression represents the first special and this expression represents the second special, then at some point they should be equal according to Elise, and that means that I can create an equation. It's an equation now because I threw in an equal sign. I can create an equation, and once I have an equation, I can solve for x. And once I solve for x, I know how many days Elise wants. So I am going to first solve by moving my x terms together. And if I want to move this 8x to the opposite side of the equal sign, I need to do the opposite operation. In other words, when 8x moves over here to the left, it's got to be the opposite, which would be negative 8x. So I would have a negative 8x on both sides to represent that I want the 8x to move from that side to this side. 8x minus 8x is 0. And so when I simplify 6 minus 8, that's negative 2. Don't forget your x. And then I still have that plus 50. And it equals, and then what I'm left with here on the right is 40. At this point, this is just a two-step equation. Once I get my x terms together, I proceed with two steps. So plus 50, the opposite would be to subtract 50. So I do that on both sides. The opposite, inverse of adding 50 is subtracting 50. I can bring down my negative 2x, bring down my equal sign. 40 minus 50 is negative 10. This 50 minus 50, well, if I have 50 and I take 50 away, I get 0. So those kind of just disappear. And then if I have negative 2x, that's negative 2 times x. So the opposite would be to divide. So I can divide both sides by negative 2. And simplify that down. I'm running out of space here. Let me adjust. And when I divide, negative 2 divided by negative 2, that's 1. And 1 times x is just x. So I simplify down to x on the left side. And then negative 10 divided by negative 2 is positive 5. So it looks like my solution is 5. X equals 5. And we established that x represents the number of days. So it looks like the answer to this question is 5 days. Now, I should probably check to make sure that is correct before I type that in final answer. And so the way I check my work is to plug 5 in for x to each of these expressions and make sure they're equal. And so what that would look like is 6x plus 50 would become 6 times 5 plus 50. And that would be 30 plus 50, which is 80. Okay. And then 8x plus 40 would become 8 times 5 plus 40. And 8 times 5 is 40. 40 plus 40 is 80. So when I substitute 5 for the number of days, I get equal values for either expression. And so I've checked my work. I know it's correct. So now I can circle this as my final answer. And that's how you can use linear equations to solve this real-world scenario.